it's time. We are now finally graphing rational functions. So to start out, we're going to talk about the reciprocal function. So the reciprocal function is just y equals 1 over x, or x to the negative first. Based on what we learned last time, if it's 1 over x, that means x can't be 0, so our vertical asymptote will be at x equals 0. And then also, if you try to divide 1 over x, we're already at a remainder. It doesn't divide. The degree is smaller on top than on bottom, so we have a asymptote at y equals 0. Then if you make a little table and you plug, like, you don't want to plug 0 in because it's going to be undefined. But if I plug 1 in, 1 over 1 is 1, so we have a coordinate 1, 1. I could put like 2 in. 1 over 2 is a half. I could even do a half, and that will be a 2. And I don't know if you notice, but they're just the reciprocals of each other, which is why it's called the reciprocal function. And you get a curve that follows those asymptotes. So one of the key points that I use is 1, 1. Then if I do some negatives, I could just switch these all to negatives and just make them all negative, right? So negative 1 would give me negative 1, negative 2 would give me negative 1 half, and so on. So we'd have these 3 points in the third quadrant following those asymptotes. So negative 1 is another key point. So if we go to the squared reciprocal function, your asymptotes will be at the same location. Even though it's x squared, you still have an asymptote at x equals 0 and y equals 0. And if I do a table, what you'll notice is 1 over 1 squared is still 1. So I have a key point still at 1, 1. If I did like 2, I'd be 1/4, right? Because 1 over 2 squared is a fourth. So it's just a little closer and so on. But it'll still look like that in the first quadrant. Now, if you put a negative in, this is where it's mostly like vastly different. 1 over negative 1 squared is a positive 1. So you'll actually have a curve following the asymptotes in the second quadrant this time. So what you'll notice is for the reciprocal function, where it's just to the first power, the arrows along the asymptote, the vertical asymptote, go opposite directions. But when it's squared, the arrows go same direction on either side. That happens for both even and odd exponents. So if you have a multiplicity that's even, arrows will go same direction. So arrows in the same direction. And then if it's odd, same direction, sorry. Odd would mean arrows are going opposite. So if this were to the third power, the arrows would still go opposite directions. But if it were to the fourth power, it would look more like the squared reciprocal function. So kind of like when you're doing like a cubic versus a squared function. Let's see how this is done though. So we're just going to use our parent function idea. So if you think about this as a parent function, this is your a over x minus h plus k. And I should have put a c right here. So the a affects the y's. The c will affect the x's. H tells you how far left or right, and you go opposite of the sign, just as a reminder. And k tells you how far up or down you go on the y's. So this is just like normal parent function things. So it should make sense, though, that we're going to go left 3, for instance, because if we set this denominator equal to 0, we'd get x equals negative 3. So I know that I have a vertical asymptote at negative 3. The k tells you how far up or down, so that's actually going to tell us our horizontal asymptote, which is just at 0. So vertical asymptote is at x equals negative 3. Horizontal asymptote is still at y equals 0. From there, this affects your y values But if you're stuck right here and you don't know what to do, just make a table. If you don't remember what the distortions are, make a table and pick something to the right or to the left of your vertical asymptote. So like a -2. And you could plug that in and figure out what it is. And then just plot the point. But if you're using key points, remember one of the main key points is 1, 1. So if we're affecting the y's, that means we're going to double the y value. So I'll go over 1, up 2. So from where the asymptotes cross, I'll go over 1, up 2. What you'll notice is if you use the table method, if you plug -2 in, you'll get a y value of 2, which is where this coordinate is, -2, 2. Okay. Now I don't need exact graphs, I just need rough graphs, so you can just have it follow the asymptote like so. And since I know the multiplicity down here is odd, I know it's going to be in the opposite, so diagonal location. And I did it wrong, so I go left 1 down 2 instead. Went to the wrong point. But if you use the table method, just plug a -4 in, you'll notice that you'll get -2 as your y, and that's because that's this coordinate, -4, -2. And there is your graph. So let's go ahead and do another one. And, sorry, I'm double checking my color, there we go. So for this one, it's good to find your shifts first. So I'm going to go, I have a vertical asymptote at 0 because there's no shift. You can also figure that out because if 2x has to equal 0, then x would have to equal 0. Horizontal asymptote, though, if there's something added or subtracted, that tells you your horizontal asymptote. So we're going to go ahead and say y equals -1 because we're shifting everything down 1. Like so. So right where those cross, it's going to be important for us. This is once again not a squared reciprocal, therefore they're going to be an opposite. So if my first point were here, my opposite one would go right here, or vice versa. If it was the first point was over here, then the second one would go over here. So now key points, if you're using key points, I would do 1, 1. Now this 2 is in the denominator, therefore it's going to affect my x's, and you do the opposite. So you do the opposite on when it's affecting the x's. So I'm going to divide the x's by 2, so I go over 1/2, up 1, from where they cross. And I draw my curve. And then since it has to be in the opposite, I'm going to go left 1/2, down 1, and draw my arrows. Now, if you're not a key point person, you want to use a table, great. Just like I said, pick one number to the left or right, so I might pick 1. And then I'll get a different coordinate than the one I plotted, but you'll still have this the same rough curve. So if I put in 1, you have 1/2 minus 1, which is a -1/2. So I'd go to the coordinate 1, -1/2 right here. And I'd plot that. And you can kind of do the same thing where that means I went over 1, up 1/2 from where the asymptotes cross. So I need to go over 1, down 1/2 to get my other coordinate. Or you can just plug in -1, and that would give you -1.5 or -3/2, however you want to think about that. Let's do one more of these special parent function ones. So this one's the squared one, so that means for instance, if the first point is in this first quadrant, the second one would be in the second quadrant, or if my first point were in the fourth quadrant, so if we were right here, then my second one would be right there, because the arrow's got to go the same direction. Let's find asymptotes first, though. Vertical asymptote is what makes this 0, so it's x equals -1, which makes sense because our shift should be that we're going left 1. Horizontal asymptote is the vertical shift, so at y equals -4. So go down to -4, voila. And then the last thing on this one is so I do have a key point of 1, 1. This is on the top, so it affects the y values. And I'm going to multiply the y values by -1. So it'll be 1, -1. So from where the asymptotes cross, I go right 1, down 1. And then back from where they cross, because they have to be, so this curve will be going down. The other curve must likewise be pointing down close to the vertical asymptote. So I'll go left 1, down 1 as well. And there would be my picture, my graph.